So let's go through what this question is asking, and we'll do just a rough sketch. I want to go to a destination 500 kilometers away, some northeast. So I'm going to say this is start, and this is end, and this is 500 kilometers. So I'm flying my airplane. I've got a wind speed here, and I've got my actual plane speed. Now that's north 60 west, the wind is north 30 east. I'm going to end up doing something like this. I'm going to say this is T1, and it's 3 hours, because I'm going to do that for 3 hours. Now, if you look at my sketch right here, we can clearly see that I'm way off track of where I want it to be. So I need to make a course adjustment and fly this way. So therefore, I'll call this T2, and I have no idea how long this is going to take. So when we talk about how much time the trip is going to take, the total time is T1 plus T2. So in order to solve T1, I need a little more information about my first motion. So let's draw a scale diagram. Now your scale is going to be different than mine because we're working a different piece of paper, but I can see on my screen that with a 40 kilometer an hour and 120 kilometers, I should be able to do a scale of 1 centimeter is equal to 10 kilometers an hour. And really what I see this as is my first motion of where do I go? So now I'm going to take a minute because these are both relative to northeast southwest. I'm going to draw a line that's northeast southwest. And I'm going to scroll off this question for a moment. So I'm going to draw it about here, I think. Because what I need to do is I need to pick a spot on here. And I need to say, what is my plane doing? I know my plane's going to go north 60 west. So it's going to be something like this. And it's going 120 kilometers. So I need to draw a 10 centimeter line. And what you'll see there is I drew something that's a little too short. So I'm going to have to take this and start again over here. And I said 10 centimeter line. That was my mistake. I meant a 12 centimeter line. So yet again, I'm going to go to north 30 east. I'm going to put my line right there. And I will draw my 12 centimeter line. Now let's think about what I know. We know my velocity here is 120 kilometers an hour. So it's a 12 centimeter line. Now I know what the plane's going to do. And I'm going to draw a line right here. Because the thing is, I also know what the wind is going to do. It's going to do north 30 east. So we're going to go ahead and we're going to do that. And I'm going to draw a 4 centimeter line. So the reality is, in this particular case, did I know where I was going? No. I knew what the wind was doing, which is I know what the plane was doing, which is 120 kilometers an hour, and I know what the wind is doing, which is 40 kilometers an hour, but I don't actually know what the plane's going to do. The plane's going to, though, do something like this. What am I describing here? Well, I'm describing vector addition. So I'm going to go ahead and draw this, and I'm going to measure this. And I'm getting about 12.7 centimeters. Everyone's going to get a slightly different number. And yet again, I'm going to draw my arrows on here to indicate that's what I'm actually doing. Now, because of my scale, this makes this 127 kilometers an hour. And I know I'm going to be traveling for 3 hours. So therefore, when I do the math, I end up with an answer of 381 kilometers an hour. And what I'd have to do now is use a protractor to measure what angle I'm traveling at. Now I can already see that's from my ruler. It says 48, but remember, this is 90 degrees here. So this 48 is really going to be 90 minus 48, which is equal to 42. So I would argue my angle is north, 42 west. This is my first piece of information. Watch part 2 to see what I'm going to do with this.